day 2. My name is Sam, and today I'm going to be talking about RESTful WebSockets. Sounds kind of like a weird idea, but my inspiration for this talk was basically working on a WebSocket project about 2 months ago, and the kind of problem that we were looking at was we had these resources that were shared across users and across many clients. And so there's a lot of different ways that this shared resource could be updated. So you can kind of think of like a Google Doc where you've sent it to 5 of your friends, you're all making updates at the same time. And so we were looking at WebSockets as a way to kind of push out those updates from the server. And so along the way, just thinking about APIs, I ended up making this concept of a RESTful WebSocket. And it's based on Django Channels, relatively new technology. And so today I'm going to tell you a little bit about it. So the way I'm going to go about this is the first thing I'm going to do is actually define what a RESTful WebSocket is. And so we're going to look at some of the characteristics that hopefully should be reviewed for most of you for the HTTP side of things, routing, formatting, stuff like that. And we're going to translate it into what WebSocket land would look like. Once we kind of have like a definition of what we're talking about, then I'm going to talk about how you actually implement it using Django Channels. And so earlier, before we were talking a little bit about channels, it's a third-party library. There's another talk today about how it works underneath. So I'm not going to really explain the internals of it necessarily, but I'm going to explain how to use it and the abstractions that it provides for you to work with WebSockets. And then lastly, I'm going to talk about Channels API. So this concept of a RESTful WebSocket, Channels gets us nearly almost the way there with everything, but there's a few things that we're missing. And so then I wrote, based on the project I was doing, I wrote this little library that you can use as well. Cool. So how are we going to define what a REST WebSocket is? So we're going to look at a few different things. The first thing we're going to look at is formatting. How should the messages be formatted? What data type are we going to use? The second thing we're going to look at is the routing scheme. So with HTTP, we have request paths and HTTP verbs and these things. WebSockets is a persistent connection, so we don't have some of those same tools that HTTP does. So we're going to figure out some other ways to route messages. Subscriptions. So I was saying before, the whole reason we were doing this is so that we could have the shared resources and we could have the server push out updates to the clients. And so subscriptions is WebSocket only functionality, and it's basically the concept of being able to subscribe to certain events, create, update, and delete to your server from your client. So we're going to talk about what sort of things should be kind of the standard and default. And then we're also going to talk about errors. As you should know, when you make a request, it doesn't always go successful. So we need to figure out what happens in that case. Cool. So first thing, this should be very easy. For this section of the talk, I'm going to kind of start with HTTP and then compare it to WebSockets and kind of translate back and forth. So for most HTTP REST endpoints at this point, we're saying it accepts JSON input and returns JSON output. Wow. All right, so for WebSockets, we're going to do the exact same thing. We're going to accept JSON input and return JSON output. The one difference, though, here with WebSockets is because I've chosen channels as the implementation, there's going to be the format of our JSON is going to be a little bit determined by channels, and we'll see an example of that later. So the next thing is going to be looking at the HTTP routes. And so hopefully this is familiar for most of you, but kind of like the standard API table as I like to think of it. So if we look at the third column, the action column, we have index, retrieve, create, update, and delete. So this should be kind of what you're all familiar with when you're thinking of what does a REST HTTP endpoint do. This is kind of the standard set of operations. And so we want to support this same set of operations with WebSockets, but like I said before, we don't have some of the same tools, right? So what's the first thing we're missing is we don't have HTTP verbs. Why? Because WebSockets is a persistent connection. So it makes the connection with the server one time, and then it maintains that connection. It's not making individual requests to specific routes, which is the second thing that we're missing. We don't have request paths. And now that's totally not true, because, or it's partially untrue, because when you start a WebSocket connection, you do it over HTTP, but like I said, after that connection has been set up, it's persistent. Right, so WebSockets, persistent bidirectional communication, like I've been saying. So now we're going to look at this, this table again, but now it's been translated for WebSockets, so we're going to point out some differences. So again, first thing we notice, no HTTP verbs. Second thing we notice is no request paths. But instead of that, we have this concept of a stream. And so the stream is actually defined by the channels library. And the way that I think about it is a stream is basically a resource. So you could have, in this case, I'll be using live blogs for my example, but you could think of it as users, as posts, as blogs, whatever your resource is, that's the stream. We still have the action key, which will become very important for kind of determining what we actually want to do. And then these last two columns here was basically taking the data from the request path and abstracting it out. So instead of /liveblogs/ID, we'll have an ID key. And instead of having like a post body or a get body, which I learned yesterday you could do, we just have a data key. So like I said, this is kind of the translation of just what HTTP has, but we want to do kind of the WebSocket specific stuff, and that was called subscriptions. And so because WebSockets are bidirectional, we can serve updates from the server to the client without actually making a request. Okay, so this is kind of like the whole reason why you would want to even use WebSockets. You don't have to pull for updates. And so now when we look at this table again, we have one more action here at the bottom, subscribe. And so when we think about what we're actually subscribing to, there is a set of events here that have been implemented by me for the Channels API library, but you're not really restricted to that. You could do all sorts of events. So the main ones are create. So when a new resource is created, you can get a message from the server about that. Update, when a given resource is updated, you can get a message about that. Update to a specific ID. So if you want to say, I only want to be notified when live blog number 2 is updated, you can specify that. Delete, you can see where this is going, where if you delete a live blog, you can get a notification about that, or a specific ID is deleted. And so when we think about subscriptions in our REST WebSocket, these are kind of the default events, as you think of it, that you can subscribe to. You're not limited to these, but this is kind of the default set of events. So errors. So with HTTP, we have this request response model, but WebSockets by nature is asynchronous. So when you send a message over a WebSocket, it's not necessarily guaranteed that you should get a response. But in our model, we do want to give a response, but we need a way to kind of keep track of messages. So we need to figure out, how will a client know if a request has failed? And if we think about what we do with HTTP, well, we have two main ways to kind of figure this out. Error codes, our status codes, our 200s, our 400s, our 500s, and everything between, and error messages, right? We can return an actual error message to the user. And we will, in fact, use those same tools with WebSockets. And so in the Channels API library, I've added a key called response status, which is the status code that you would expect, and the errors key, which would be a list of strings or objects for the actual errors. Now, there's one more issue, though, we have to kind of unpack, which I was saying is that WebSockets by nature are asynchronous, so you can imagine a situation where I send a request, I've subscribed to some update, the next message I get back is not necessarily an answer to my request, it's a new event that I had subscribed to earlier in the application. And so the way that I've kind of approached that problem is to use a request ID. So when the client makes a request, they can pass along a generated GUID, which would be unique per connection. And then when the server makes a response, it will include that ID. And then in your JavaScript, as you're managing your promises or whatever, you can key those by ID. So you can say, okay, I made this specific request to update a resource, and now my listener here is keyed by this ID. Okay, so to review kind of our definition of what a REST WebSocket is, we're saying it's JSON formatted. We're saying it has a CRUD interface, that same list of index, retrieve, create, update, delete actions. We're saying that it supports subscriptions to events, like creating, updating, and deleting, also filtered by ID. And lastly, we are going to show errors via response codes and messages and keep track of our requests with a request ID. All right, so now that we've kind of figured out our definition, we're actually going to talk about the implementation. And so, like I said before, for this particular project, I chose Django Channels, largely because we were already using, we had already decided on Django and had used Django Rest Framework previously. And so Django Channels is still relatively new, and we wanted to take a shot with it. So Django Channels has two main abstractions that I'm going to be talking about today on how you actually use the WebSocket stuff. And the first one is called consumers. And so consumers consume channels, right? It's basically in the name. So I like to think of them kind of like a Django view. And so if you think of the simplest version of a Django view or a Flask handler or anything like that, it's basically a function that takes a request object and returns a response object, right? That's what a view, an HTTP view is. A consumer is almost exactly identical, except instead of a request, we call it a message, and there actually does not have to be a response. It doesn't have to return anything. And so as we think of how do we kind of manage the differences, well, a view is mapped to HTTP. When you think of a view, it's in the context of HTTP already, whereas a channel isn't necessarily mapped to a specific protocol. It could be, you can arbitrarily create new channels. So I don't want to go too deep into that, but as we think about, okay, this is supposed to be a WebSockets, I understand consumers, right? Consumers are consuming a channel, and the channels library provides channels that you can listen to get those WebSocket messages. So what are those individual channels? Well, there's three of them. The first one is connect, WebSocket.connect. The second one is WebSocket.receive. And the last one is WebSocket.disconnect. And so these correspond with when you make a WebSocket connection, when you receive a message, and when you disconnect. So this consumer class will listen to these channels and be able to respond to our clients over WebSockets using the channels library. Okay, so now that we kind of have a concept of a consumer class, we're going to look at examples, and hopefully this will be more concrete for you. So the first consumer class we're going to look at is called the JSON WebSocket consumer. So you might be able to guess what the JSON WebSocket consumer does is it handles the encoding and decoding of JSON for WebSocket messages. So if all you want to do is basically have a simple WebSocket that talks back and forth with some JavaScript and sending JSON, you probably only need this class. And so here's kind of a simple example. We have some JavaScript here. This would be kind of your front-end client. Create a new WebSocket connection, encode our JSON as a string, and then finally we send the message. Cool. So on the other side of things, we have here an example consumer class, and it subclasses the JSON WebSocket consumer. And so the JSON WebSocket consumer gives you the receive method, which you can define and do something with that data. Pretty simple. And so here's the class. And now when we think about, okay, you were talking before about those channels, right? The WebSocket connect, the WebSocket receive, the WebSocket disconnect. How do I tell Django, here's this consumer, I want to listen to these channels? Well, here's how you do it. And so typically you would put this in a routing.py file, and you define this channel routing list, which is similar to your URLs list in URLs.py for Django. And so it gives you here this route class helper, and you pass it a consumer function, and it knows how to pull out the channels that it's listening to. And if you look at the source of JSON WebSocket consumer, you'll actually see the dictionary where it defines, hey, these are the WebSocket channels I'm listening to, call these specific methods with it. Okay. So I said kind of that a consumer was kind of like a view. So if you're thinking REST, you're thinking, okay, I have live blogs, I have posts, I have all these REST resources, and I have this consumer class. So I'm going to make a live blogs consumer, a post consumer, a users consumer, all these sort of things, and be done with it. Not quite. There's one problem with that. And the problem is you can have multiple consumers listening to the same channel, which we don't really want in this case, because if we had multiple consumers listening to the same WebSocket channels, then when you would have one WebSocket message go through, you would instantiate all those consumers to listen to that message. That's not really what we want. We want that message to be received and then routed to our specific controller action as it would be, right? We are taking a live, okay, we can see we're on the live blog stream, we want to create it. That is handled by this method over here, not routing that message to 50 consumers and have them process that individually. So handling the case where multiple consumers are listening to the same WebSocket. And so Channels has our back on this and provides another class called the WebSocket D multiplexer. And so the D multiplexer is responsible for handling multiple streams and routing them to individual channels. And so the way that it does that is by adding two keys to our JSON, a stream key and a payload key. So earlier I was saying with our JSON formatting that channels was going to slightly determine our format. This is where it's happening right now. So we're going to look at this example again now that we're using the demultiplexer. So not much has changed. We have a data object here, and we've added our two keys, our stream key and our payload key. And again, we're encoding the message as JSON, and we're sending it over the wire. And so when we look at the other side of things, the Python side, we see here we have an example demultiplexer class. It subclasses the WebSocket demultiplexer, which is based on JSON WebSocket consumer that I had shown you previously. And the way that this class works is it defines a mapping key, and the key here of the mapping is the stream name, and the value is the channel name. So what does this class do? Is it listens on WebSockets, it looks at that stream key, and it says, oh, live blogs, I'm going to send this message to the live blog channel. And so at this point with our example, though, that message is being sent to another channel that no one's listening to. And so here again is the routing, just to show you that the routing is done the exact same way. But to reiterate, so now we have, in our example, we're sending a message over WebSocket. It's getting picked up by our demultiplexer class. It's looking at that JSON data. It sees the stream key. It sees the payload key. It says, OK, that's a live blog stream. I know that stream because of my mapping here, and I'm going to send it to the live blog channel. So we need another thing. We need another thing to listen to that message, right? I said that channels aren't necessarily tied to a specific protocol. And this is an example of that. So the other thing we need is another abstraction provided by channels, and it is called bindings. And so the purpose of bindings is to automate the process of tying a Django model to front-end JavaScript. And the way that it does that is by supporting inbound messages and outbound messages via signals. And so we can accept messages coming inbound to create, update, or delete, and we support pushing messages from the server to the client by using Django signals, which is a feature of the Django framework to basically tie functions into certain events. In this case, it would be model events. And so because bindings are aware of their stream, if you want to use the bindings class, you have to use the demultiplexer class. You can't map a binding directly to a WebSocket per se. Okay, and also bindings are relatively new. When I first started this project, bindings didn't actually exist. And so I re-implemented a lot of the things that we have in channels now. And so in preparation for this talk, it was a lot of fun because I got to use all the new binding stuff and learn a lot about them, but they're still relatively new. So I see this, it kind of depends on your perspective. You may not be in a position where you can use an unstable API, but an unstable API also means that you can give feedback and you're more likely to be able to change it if things don't work well. So first class we're going to look at is the WebSocket Binding class. And the WebSocket Binding class only implements create, update, and delete. So if we think back to our definition of what a REST WebSocket is, it is not only just create, update, and delete, but retrieve, list, and subscribe as well. So let's look at an example of this. So this is the same example, now getting a little more complex. We have our WebSocket connection. We have the stream, live blogs. We have the create action. And now we have our data key here. And this is the data we're going to actually use to create the live blog. Just has a title. We encode the message, and we send it. On the other side of things, we have a live blog binding class, the WebSocket Binding, and it takes two class level parameters, the model and the stream live blogs. And so to route this class will be a little bit different than our previous example. So we have the demultiplexer here, like I was saying, because the demultiplexer is required. And then we define a route here, giving it the channel name, which, if you remember that, the mapping, we had live blog channel. And then we give it our consumer class. So consumers are the only thing that can consume a channel. And what the binding class does is expose a consumer. And so there's some good reasoning to do this is channels has other consumer decorators that you can use. And so by having the binding expose this class function like this, it makes it easier to wrap that function with other decorators in that library. All right, so like I said, we needed to implement the other three methods for our REST WebSocket. And that's where my library comes into play that I've called Channels API. So Channels API provides a resource binding, and it was largely inspired by Django Rest Framework's model view set. And so if you've looked at the source code of that class, you'll see that basically that class is composed of multiple mixins. And so I've used the same kind of pattern here as model view set, in that I've abstracted each one of the create, update, delete, list, retrieve, subscribe into its own mixin class. And it also supports the subscriptions that I mentioned before. And then lastly, it's based on model serializers. So you'll see here in our example that to handle the deserialization and serialization of data, it just used the serializer class. Cool. So our final example here is showing the subscribe functionality. So we're creating our WebSocket connection. We've built a data package here that has our stream key, it has the payload, the action is subscribe. We're telling what event we actually want to subscribe to, in this case create events. And we're also sending that request ID parameter so I can keep track of which request was handled, or which promise is waiting on which response for which request. And so now here on the other side of things, so the first thing we're going to do is create that model serializer. So this is what a model serializer looks like. If you've never seen it before, it has a model class field, a fields sequence, and a read-only field sequence. Then we're going to add the resource binding class. So this here, again, is not from Channels, but from Channels API. But it's very similar. We're only adding two more extra variables here, serializer class and query set. And last thing to do is to route it all up. So here, again, we're using the D multiplexer because that's required with a binding. And we've routed the channel to the actual consumer. Awesome. So let's take a look at what it looks like in action. So for this demo, this is posted online. There's a great repo called Channels Examples. And Channels Examples shows a few different example apps using the Channels framework and how you would implement it. And so I made a fork of that to drop in my library to work with one of the models here. So since all the examples were live blogs, we're going to do a live blog demo. And the first thing I'm going to do is subscribe to an event. Autocomplete. All right, so here's our message. It has a payload of the action subscribe and the data with action create. And so now we're going to send this message. And so on the left, you can see here we got a response from the server with a response status, no errors. And we didn't pass a request ID, so we didn't get one back. Cool. So now we have another tab here. And so in this tab, I'm going to actually create a resource. Sorry. How's that? A lot better, huh? Okay. Cool. So for the first create, I'm actually going to, whoops. I'm actually going to make it fail. All right, so in this message here, we have our stream and our payload keys. We have a data key with nothing in it, and the request ID. Cool. So now let's send the message. And so you'll notice here, one, nothing happened on our on our left window, which is what we expected. And on our right window here, we got a response back. It has the same request ID that we made. It has a response status of 400, and it gives us an error message saying the title is required. Okay, so I think we can fix this by giving it a title. And now we'll send it. And so you should have seen two messages come by here. Oh, yep. The first one here on the right was our response to our individual request to create a live blog. And then we have a subscription message here that told us a new live blog was created. And so the difference between the messages you can see here, we don't have a request ID, we don't have errors because we didn't actually make a request. Only in this context, on this side, did we actually make a request, whereas here we're just getting an update. Cool. So yeah, that's pretty much it. Thank you for listening. My name is Sam Bolgert. If you want to see Channels API or the example I did, you can find it at my GitHub, Linux Lewis. Yeah, open for questions.
Hi. So you talked a lot about WebSockets.
Yes.
With Channels API. Do you know, is there any like tools that would help you do server send events with the Channels API yet, or is that something?
So bindings is the first kind of push for that, that abstraction. And in the bindings class, there's a method called group names. And so you can implement, I just showed kind of create, update, delete. You could create your own whatever with that method. So look at the group names method on the bindings class.
Did you look at the WC3 WAMP protocol at all before you?
I did look at WAMP. I believe that requires an additional server, if I'm...
A router, yeah.
There's another router server. So that was the first thing I was going to try. And I asked Andrew if it was possible to do with channels, and he said maybe, and we were kind of keen on using that. So, but yeah, I have seen that before.
Any other questions? Well, thank you.
Thanks, everyone.